Hello everyone. So now we'll start the next topic in the virtual memory. We have discussed as in the previous topics, that is demand paging. So what is demand paging? You know it is. So you are demanding the one page by the CPU for the execution, or you are loading the instruction from one of the page, and that page is not in the memory, or it may present in the memory. So when you demand the page, if it is not in the memory, what happens if there is a no free frame? Means what here, when there is a page is demanded and if that is not present in the memory, you are going to raise the page fault. And as we have discussed in the previous classes, just I will take back to a previous class. So this is how page fault is going to be handled. Here you are trying to load m from the page table, and if it is not there, it is set to invalid. Then CPU will trap the error into the operating system, saying that there is a page fault. Page fault means page is missing. That is a missing. If it is missing, the operating system will start locating where it is reside in the backing store, and then we are going to load into the memory in the free frame. Here if there is a free frame available, that page is going to be bring into a memory, or we are going to load here. Now the question is, if there is a free frame, we are going to load that page into the memory. But what is going to happen? What happens if there is a no free frame? Then we are applying the page replacement methods or algorithms. So what actually we are doing here, page replacement, find some page in the memory but not really in use, swap it out. Means if there is a pages, they are occupying the space in the memory and they are not really in use, simply what we are going to do, swap it out or swap out those pages. That also we have covered in the previous topics, how we are going to swap out and swap in. So performance, which method or how you are going to measure the performance of the page replacement algorithm. So want an algorithm which will result in a minimum number of page faults here. Same page may be brought into a memory several times when there is a no free frame available, and we are using, if you are using the page replacement algorithm. So we'll go on discussing what is a page replacement. First we'll see, then we'll go for discussing the algorithms. So prevent over allocation of a memory by modifying the page fault service routine to include the page replacement. So use a modified bit to reduce overhead of a page transfers. Only modifies the page are returned to the disk. Page replacement completes a separation between the logical memory and the physical memory. Large virtual memory can be provided on a smaller physical memory here using this page replacement algorithm. So how actually it is going to work here? Need for the page replacement here. So when you are going to load a instruction M, and that is resided in the 4, that is valid here. If frame is, that page is resided in the fourth frame, and that bit is set to valid, means that page is in the table. Logical memory for user 1, page table for the user 1. So like that, logical memory for the user 2, page table for the user 2. A, B, D, E here. So valid bit and invalid bit 6 to 1. So which pages are there? A, D, E are there. B is not in the memory. So this is how actually we are going to do. And this B and M are in the backing store page. So now what is going to happen here, if any of the user requesting the page, like consider here in the user 2, page B is not in the memory, then if you are requesting or you are going to use that page, it will raise the page fault and it will verify the pre-frame. Now the pre-frame is there, it will be loaded, or it will check here, is there any free frames are available? Now there is a no free frames available in the physical memory. All memories are full here, all the memories are full. So there is a need of page replacement. Just here, monitor, the first two blocks are used by the monitor, the second frame is used by the D, and third frame is used H, fourth frame is used by the load M, fifth frame is used by the J, sixth frame is used by the A, seventh frame is used by the E here. So now what is going to happen, process user 2 want to load the page B into the physical memory. Now there is a no page, that page B is not in the memory, then it will raise the page fault. Once the page fault is raised, it will locate where it is in the backing store, then you are loading into the memory. When you are loading, you are going to verify the free frames here. So there is a no free frames, then there is a need of what? Page replacement algorithm. So now we'll go to the next, how you are going to implement a page replacement algorithm. So basic page replacement algorithm here. We are going to discuss basic page replacement algorithm. So first step is what here? Find the location of the desired page on the disk here. When there is a page fault raises, first we have to locate the page in the disk. So you find a free frame. So now once the page is located, you have to find a free frame. If there is a free frame, use it. Means if there is a free frame in the physical memory, the located page is loaded into the memory. Now what is here? If there is a no free frame, so then what we are going to do here? Use a page replacement algorithm to select a victim frame to make free here. So now the question is how to decide which is a victim page, that we are going to discuss in the later algorithms, that is FCFS, LRU and optimal page replacement algorithms. So now what you are going to do here, read the desired page into the newly frame. Once you identified the victim page or a frame, that will be swapped out, that page will be swapped out into the backing store, and you make a free frame, and you have to read the desired page into the new frame, and then update the page and the frame tables. So after updating, now the page is available in the memory. What you are going to do? Step 4 is restart the process. These are the 4 steps we are going to follow when there is a need of page replacement. After knowing this, we'll go on discussing page replacement algorithm. Before that, just you take a one example, that is a diagram. So now this is a page table here, 0 and F. F is a frame that we are going to divide here. So what are the steps here? Step 1, if there is a page that you want to load into the memory but there is a no free frames, what you are going to do? Swap out the victim page. Victim page is swapped out, and swap in the desired page that is required by the user for the execution. So after swapping in, what you are going to do here? Change the bits here. When you swap out, change the bit to I, and when you swapped in, change the bit to P. Like this we are going to do the or carry out the steps for the page replacement algorithm. So once you got it, what is page replacement and what are the steps for the page replacement, you will study the page replacement algorithms here. So we have to select or design the page replacement algorithms by considering this. So want lowest page fault rate, you design algorithm that will produce the lowest page fault rate, that we will discuss in the later part of the syllabus or later section of this virtual memory management. And now evaluate the algorithm by running it on a particular string of memory references and computing the number of page faults on the string here. So in our consideration, we are going to consider if all our examples, the reference string is 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. This is the example we are going to consider here. And this is a reference string, and these are the page numbers we are going to load into the memory using the different page replacement algorithms. And this is a graph of the page faults versus the number of frames here. The number of page faults and the number of frames here. There is only one frame, then there is a more number of page faults are there. If there is a two, it will go on. How the number of frames go on increasing? Number of frames are go on increasing. Automatically, the number of page faults are go on decreasing here. This is about the graph that is shown here. Once you got the graph of the page replacement algorithms, so which are the algorithms we are going to cover here? There are 4 different algorithms we are going to discuss. Just I will write which are the 4 different algorithms we are going to discuss. There are 4. One is first in, first out algorithm, and second one is LRU, and third algorithm is optimal page replacement algorithm. These are the three different algorithms that we are going to cover in the remaining part of the presentation. First in, first out, least recently used and optimal page replacement algorithm. To improve the performance of these three algorithms, and some more algorithms are there or modified algorithms, those will go on discussing in the remaining part of the syllabus. Thank you.